we know some basic concepts of HDFS. In this section, we will talk about the architecture of HDFS.
Well, actually, HDFS uses the master-slave structure. An HDFS cluster consists of one name node and multiple data nodes, as shown in the figure. At the central server, the name node manages the namespace of the file system and the access of clients to files, while data node runs a data node process to deal with read or write requests from file system clients and create, delete, replicate data blocks under the unified scheduling of name node. We've said that the name node maintains the file system namespaces. The HDFS namespace contains directories, files, and blocks. HDFS uses the traditional hierarchical file system structure. Therefore, users can create and delete directories and files, move files between directories, and rename files in the same way as using a common file system. Any changes to the file system's namespace or its properties are recorded by the name node. HDFS is a distributed file system deployed on a cluster. Therefore, a large amount of data needs to be transmitted over the network. All HDFS communication protocols are based on the TCP/IP protocol. The client initiates a TCP connection to the name node through a configurable port and uses the client protocol to interact with the name node. The name node and the data node interact with each other by using the data node protocol. The interaction between the client and the data node is implemented by the remote procedure call, short of RPC. Actually, the name node does not initiate an RPC request, but responds to RPC requests from the client and data node. The client is the most commonly used method for users to operate HDFS. HDFS provides a client during deployment. The HDFS client is a library that contains HDFS interfaces, which hide most of the complexity of HDFS implementation. Strictly speaking, the client is not part of HDFS. The client supports common operations such as opening, reading, and writing, and provides a command line mode similar to shell to access data in HDFS. HDFS also provides Java APIs as client programming interfaces for applications to access the file system. One name node greatly simplifies the system design, but also brings some obvious limitations. The first is namespace limitation. The name node is stored in memory, therefore, the number of objects that can be stored on name node is limited by the memory size. The second is performance bottleneck. The throughput of this entire distributed file system is limited by the throughput of a single name node. The third one is isolation problem. Because there's only one name node and one namespace in the cluster, different applications cannot be isolated. The fourth one is low cluster availability. Once the only name node is faulty, the entire cluster becomes unavailable.
Okay, in this part, we talked about the architecture of HDFS. Next, let's see some key features of HDFS.